So in this video, we're going to take a closer look at how to set up Visual Studio Code and how to use Visual Studio Code to get some data analysis done. So we're not going to write any code, or at least we'll write minimal amount of code. And what we really want to do is to get the AI to write the code for us. So we're just going to use normal prompting to get the code written inside of Visual Studio Code. What I want to assume at the moment is that you've got the following installed. So on the screen you can see python.org. So I am going to assume that you have Python installed in your system. If you do not, go to python.org and go to the download section. Choose the version correct for your operating system and follow all the guides as you do the installation. You can just accept everything that comes with that installation. I'm also going to assume that you have Visual Studio Code installed. And for that, you can do a normal Google search or a Bing search and you get Visual Studio Code. Once again, you are going to download the version specific for your computer. I do want to warn you though, if you are on a Mac, if you do download the Mac version, it's just going to sit in your downloads folder if that's where you do your downloads. What you want to do is wherever it was downloaded, drag that file into your applications folder. Otherwise, it might just always sit in your downloads folder, and every time you start this, it is starting it from your downloads folder, which is not what you want. So just drag it straight onto your applications folder. On the Windows side, again, you can just follow the installation prompts and just click or accept at least everything that it suggests. I'm also going to assume that you have a GitHub account. Very easy to do. You go to github.com and you create an account. Now, if you are at an institution of education, higher education, you can sign up for this. Look for GitHub Student Developer Pack. Once again, you can do a Bing or Google search for that. And sign up for Student Developer Pack. Now, that is going to give you access to GitHub Copilot, the Pro version, so that you can get, that version that you have to pay $20 a month for. You can get that absolutely for free. It takes some time for them to verify the fact that you are with an institution of higher education. It's slightly more difficult from time to time as they change their processes, because you might have that your university has moved from a physical ID card to a digital ID card, and somehow Microsoft hasn't kept up with that. Remember, GitHub does belong to Microsoft. So it takes a couple of days, and you might have to do a couple of emails back and forth to get this activated, but it's well worth your while because you're going to get the Pro version. I'm going to call it the Pro version because that gives you access to just so many more of these large language models. And that's what we're going to use to write the code for us. So even if you've never seen Python before, it really is of no consequence. We can really get the LLM to write the code for us inside of Visual Studio Code, do the analysis for us in Visual Studio Code, and you'll see how easy that is to do. Now, as the code gets written, you'll start to learn how to code. You'll see the code that the model produces, and it really is. I think it's a nice organic way to learn how to code. So sign up for the Student Developer Pack. As I say, just bear in mind that it might take a couple of days or two, and you might have to provide various forms of proof that you are actually with a university or institution of higher education. So here we are in Visual Studio Code. I've installed Visual Studio Code. It is available on my system. Do remember, if you're on a Mac, that you just drag that file, because it's going to be the single Visual Studio Code application itself. You have to drag that across into your applications folder. And this is what a blank screen looks like. You'll see that I would have some recent files or folders listed here, projects that I'm working on. The first thing that we might want to do is come here on the left-hand side. You'll see there is a button there for extensions. I'm going to click on extensions, and if you've never coded before or used an integrated development environment such as this, you can think of these as plugins. It's just added things, or things that you add to this Visual Studio Code that allows you to do more with it. And a couple of things that we really want to install. So right at the top there, you see search extensions in the marketplace, and the first one that you want to install is Python. Even though you've already got Python on your system, and please do first install Python before you do this, just search in the marketplace for Python. Do take the official version from Microsoft. That's always the safest thing to do, just to allow Visual Studio Code to recognize that you do have Python on your system and that you can code in Python. Other things that you might want, you can see I've got GitHub Copilot here. If it's not installed for you, again, just search for that. Once again, if you've signed up for that, Student Developer Pack, you are going to get this absolutely free of charge. You won't have to pay the $20 a month. A couple of other important ones here on my list is the following. Jupyter, Jupyter, that stands for Julia, Python, and R. It's a little acronym there, putting those letters together to give us the name. Jupyter Notebooks, that is going to be our coding environment. It is the de facto standard. I'll go so far as to say that it's the de facto standard in data science and statistical analysis these days. You're going to see the rich documents, research documents that we can create with Jupyter Notebooks. So those are the important ones. You'll see I've got quite a few other things installed. You can look down that list. A Python debugger, Python for data science, the extension pack, Python itself, the language support. Once you click on one of those to install, it'll automatically install some of the other extensions as they are required. I'm going to go back up right at the top on the left hand side. That is where we find our Explorer, and that's the where we can get to folders on our system. You can see that you can also clone a GitHub repository that is slightly more advanced. We won't get into that in this lecture. What we want to do is to open a folder. There is an easier way to do this though. You can just open your Finder or your Explorer and you can just drag a folder straight onto this empty section. That's what I'm going to do. So I've literally just opened my Finder or folder Explorer and just dragged a folder on there, and you can see it's very small at the top, but it says Data Analysis Demonstration. So that is the name of a folder, just in my Documents folder. One way that I do like to work though is to keep all my data inside of that folder as well. So if I'm working on a project, all my data files live in that same folder. So you can come up with your own way to work. You might have your data folders somewhere else, but I just find it's very easy just to have all my folders, all my files at least, in the single folder. So you can see it's called icu_mortality.csv, and it is synthetic data about ICU mortality. It's a CSV file, so comma separated values. That is the safest data form to bring into Python or R or many other coding languages. A comma separated value file is a spreadsheet file, but it just removes all the extraneous bit that programs such as Microsoft Excel would add to your file. It just gives you the absolute rows and columns of the actual values. Nothing has been changed or formatted or colored or tables and stuff. Nothing is brought in other than the rows and columns of actual raw data. And that is the safest way to import data. Now, the first thing that I need to do is to create what is called a virtual environment. Now, you do have Python installed on your system, but you never ever want to, shall I say, mess with that installation. The thing about Python is so many people have created packages, libraries for Python that extends the functionality of Python. And these things usually have interdependencies. Someone might develop a new package, but inside of that package, they depend on other people's packages. And you do develop what is called package nightmares, where you break dependencies between packages and you might just land up in package hell, as they say. And so we never want to mess with the installation of Python on our system. What we do want to do is to create a copy of it right inside of a folder such as this. So I do like to work in the folder structure. This is going to be my whole project. It's going to live in this folder on my internal drive. And I want to make a virtual copy of my system Python inside of this folder. That's the thing that we want to do. And what we're going to do inside of Visual Studio Code, we're going to hold down Shift, Control, and P. And on a Mac, that would be Shift, Command, P. You can see a whole list of these commands that you can execute inside of Visual Studio Code. And it'll populate at the top with ones that you've recently used. So you won't see this. The ones that are at the top for me, and you might just have to type a few things. So what you would like to type is the second one there, Python, space, create environment. It'll be down the list. You can see we start at A, B, C, so that's going to be way down the list. But once you've used it, it'll come right to the top to these recently used sections. So Python, space, create environment. That's the one I want to click on. And then right at the top, you will be given an opportunity to decide what kind of virtual copies you will make. Now, if you have mini Conda or Anaconda installed on your system. You'll see Conda there as well. That is not what I want. Just to be safe, because it does not require any extra installation, go for VENV. It stands for Virtual Environment. So I'm going to click on that. What will appear now is a list of the versions of Python on your system. So if you've followed all the instructions, the default settings as you downloaded and then installed Python, Python will be recognized here right inside of Visual Studio Code, all the versions of Python on your system. So I've got 2 versions of Python on my system as it stands, 3.13.2 and 3.12.10. I'm just going to choose one of the newer ones. Now we're already at the stage where we're going to 3.14. I tend not to go for the very newest ones because I am going to make use of external packages and libraries, and they might not all have been optimized yet for the newest versions. So always go to a slightly older version, and that's what I have here at the moment, 3.13.2. I'm going to click on that, and at the bottom right we'll see it is creating my virtual environment. What that is doing is just creating a virtual copy of my Python system, that's Python that's on my system here inside of this folder structure. Right at the top left you'll see .venv. That's a brand new folder that didn't exist before. .venv. That's where the copy of Python is being created as we speak. So it's right there now, and we're ready to go. Unless we want to make use of extra packages, and that's exactly what we want to do. We do want to make use of extra packages. So how do we install those? Well, I'm inside of this folder. I do have my virtual environment. I'm going to hold down Shift Control and hit P, or Shift Command and hit P. And the next one I want to search for is this second one. So you can see they're right at the top for me because I use them all the time. And that's Python :space and then create space terminal. I'm going to create a Python terminal. That's going to appear right at the bottom of your screen. If you look very closely, depending on your screen size, so I'm working on a very big monitor. And on the left-hand side, we can see the set of parentheses and then .venv. That's telling me I am inside of this virtual environment. So if I do any installations of extra packages, it's not going to be in my system. Again, I don't want to mess up my system installation of Python. All my installs are now going to happen inside of this venv. If you don't see this, then something has gone wrong. So just pause, go back, and follow the instructions. Now what I want to do is install, and the command for that is pip, P-I-P. So pip space install, and now I'm going to install the list of packages that I do want. Now there's quite a few that we're going to use very commonly in data science. I'm just going to start listing them. The ones that I do like though to add is just IPy widgets and TQDM. So I'm going to say, let's do TQDM. We're also going to do IPy widgets. And don't put any commas in between. Then NumPy, N-U-M-P-Y for numerical Python, SCIPY for scientific Python, PANDAS, that's pandas, and that's going to be the package that works with our spreadsheet files. I'm also going to install something to plot with. That's going to be matplotlib, M-A-T-P-L-O-T-L-I-B, matplotlib. I might want some other plotting packages as well. A famous one is Seaborn, S-E-A-B-O-R-N, Seaborn. I also do like Plotly, P-L-O-T-L-Y, Plotly. So you can always come back inside of this terminal and just add extra packages by saying pip install. So I'm just going to hit the enter key, and that's going to install inside of this virtual copy. So you can see it's going to go in that .venv folder. It's just going to add all these packages for us. Great, it looks like all my packages were installed. Now they are inside of this folder. Whenever I open this folder and work on this project that's inside of this folder, where my spreadsheet file lives as well, I will have access to all these packages inside of the Jupyter notebooks when I use my Python code. So what we can do now is just to close this panel. You can see hide panel. I'm just going to click on that and close that. And what we are now, we're at least at a time where we can actually create a new Jupyter notebook. I'm going to go here to the left-hand side where it says Data Analysis Demonstrations. Remember, that's just the name of the folder. If I go over to the right-hand side, you see these little buttons that come up. I'm going to click on the very first one that says New File. and I've got to name this. So I'm going to say this is going to be our summary statistics or our exploratory data analysis. So let me just call it EDA. It's just the name of a file, so you can call it what you want. What's very important is to have the IPYNB extension. So .IPYNB, short for IPython Notebook, because Jupyter Notebooks, when they started out life, they were called IPython Notebooks. So we have the legacy of that file extension. So call your file whatever you want, as long as you have .IPYNB. If I hit enter now, you see that I have a brand new Jupyter Notebook. I'm going to give myself a little bit more space. If I click on the File Explorer, or the Explorer at least on the top left, it'll just collapse that area. So this is a blank Jupyter Notebook. We will have a video where we're going to set up an agent, and the agent is going to do all of this for us. It's going to create our notebook. It's going to fill in, complete our notebook for us. But for now, we're just going to do things very manually. At the top right, you'll see select kernel. Now the kernel is the programming language that you want to run. Now we've created a virtual copy of Python inside of this folder structure. That's the one we want. So I'm going to click on select kernel. I'm going to scroll down until I see Python environments. Click on that. And there you can see I still have my system Python versions there, 3.12.10, 3.13.2, not the ones I want. I want this first one, the one with a little star, the .venv, then Python 3.13.2. That's the virtual environment that lives inside of this folder. So that's the one I want. Now you can see it's changed to .venv and then Python in parentheses. So I am running this virtual copy of Python that is inside of this folder. So let's just quickly look at how a notebook is constructed. Well, it's constructed by creating individual cells, one below the other. Although you can drag and drop them, you can take them higher up the order, lower up the order. If I hover right in the middle of the notebook, you see these three buttons appear. There'll be generate, code, and markdown. So generate is going to generate some code for us based on a chat. So that's going to be the large language model. Then we have a code cell and we have a markdown cell. So the markdown cell is just where you would place normal text. So let's start with that one. So I'm going to click on markdown cell and you can see I have my very first cell. It's marked down so I can just write normal English as I would in a word processor. Now, instead of a word processor that has all sorts of buttons that you can push for the size of the font or for making your characters bold or italic, you have to do this with what is called markdown language. It's a markup language. In other words, there's little symbols that you use that'll tell this editor what you want that text to look like. And the first one we're going to look at is a single hashtag and a space. So you've got to have that space there. That is marked down for, please give me back the largest font size that you have available right here in the notebook. And I'll say this is going to be exploratory data analysis. Now, if I want to execute this cell, every cell is something that I can execute. I'm going to hold down Shift and hit Enter or Shift and Return while I'm inside of that cell. And look at that. We have our first cell. Can you see how big the text is? That's absolutely fantastic. So now you see if I hover in the middle, I can add new cells above that cell, or if I hover at the bottom, I can add a new cell below. So we can add a new cell below, but when you've hit Shift and Enter or Shift Return, a new cell was going to automatically appear for us. In the right corner of that cell, you can see what cell type it is. It is a markdown cell right now. So we can just use that, or let's just hover in between and just add another markdown cell. It'll be between the two, the one that we've just created and the one that was created for us. I'm going to use a new kind of markdown notation, and that's going to be the greater than symbol. And I'll just put my name. I'm going to say docjhk. Now I'm going to hold down Shift and hit Enter or Return. And you see what it's done is it's put a little blue line there. Now, depending on the theme that you're using, it might look different for you. I'm just using the default theme. And it's put a little blue line and it's created this whole sort of grayish background and it's written my name there. So can you see that we're just controlling the way that the text looks by these little symbols. And so let's do another one. I'm going to do Markdown again. Now I'm going to use 2 hashtags that's going to be slightly smaller font size. And I'm going to say Python imports. So I'm going to hold down Shift, hit Return or Enter, and you see it's slightly smaller font size. And you can go up to 6 hashtags. It'll be the smallest. That'll be a subsection. And so you have great control over how you section your notebook. If you don't use any markdown symbols, then it's just going to be normal text. Let's do that. Since we have this text, it says empty markdown cell. I can just double click on that. That'll open that cell that's been hovering around, the one that just keeps on moving down because it was automatically generated. I'm going to say, as we import the required packages in this section. Normal English, there's no symbols there to control the size. If I hit Shift and Return or Shift and Enter, you can see that's just going to be normal text. So now let's open our first code cell. So I'm going to open a new code cell there, and you can see on the right hand side of it, it says Python. So this cell is going to contain Python. Now this is where I'm going to import some of those packages that we installed inside of this virtual environment. And the way that we're going to do that, I promise that we will type a little bit of code. Now you can get the large language model to do this for us, but I might as well show you how to do this manually. So I'm going to say import, and I'm going to import NumPy. And you can see the auto completion there. It says import NumPy as NP. Now one great thing about Python is it kind of tries to save you time, in that you don't have to type NumPy, NUMPY, every time that you want to use some of the functionality inside of that package or that library. Instead, we use what is referred to as a namespace abbreviation, so NP. So every time I want to use something inside of the NumPy package, I just have to type NP dot and then whatever I want to use. So that saves a lot of time. You can see also there was some other autocompletion. The system thought that I would also like to import matplotlib, and I definitely want to do that, so I'm just going to hit the tab key. And that just accepts the code that was written for me. Now the matplotlib is a very large package. It creates plots for us. Inside of that very large package are a different set of modules. And the module that we would like is the pyplot module that creates Python plots. And that's why it says import matplotlib.pyplot. So that's the only part of matplotlib that we want to import. But once again, I don't want to type, long words every time I want to use something inside of that. So we're going to use this namespace abbreviation again. And the common one to use is this PLT. So I would just have to type PLT dot and then whatever plot I want, because that functionality, those functions live inside of matplotlib. Let me hit the enter or return key. And look at that. It says from SciPy stats import norm. Now that's definitely not what I want. I would want to import the whole stats module from SciPy. Now in the beginning, you're not going to know this, but later on you'll see when we use an agent in future videos, when we use an agent, you won't have to worry about any of this. But I'm going to say from SciPy, from Scientific Python, import the stats module. Now stats is a fairly short word. I mean, it's as long as NumPy, so I suppose, my argument falls flat a little bit. But I am happy to type stats dot, and I might want to type stats dot t-test. Well, there'll be a t-test for independent groups. There are all these functions, but I'm happy to write stats dot, so I'm quite happy to do that. I don't want scikit-learn import at the moment. What I do want is just to say import pandas as PD. And when you've used Python a few times, these things are going to become second nature. Once again, you don't have to worry about them right now. Eventually, we're just going to get an agent to do all these things for us. I'm happy with where it stands as far as the analysis that I want to do in this notebook. Those would really be the basic imports that I want to do. Now, do remember, this is not going to execute unless you've installed those packages, NumPy, Matplotlib, SciPy, Pandas, which we did when we opened a terminal and we said pip install, and that installed these packages inside of our virtual environment. Now, I'm going to hold down Shift and hit Enter or Return, and it's going to complain at me. It's going to say, hang on a minute, you forgot one of the packages that is required, and that is the IPyKernel package. That's going to use interactive Python, because that's exactly what we're doing here. We're using Python not as a long, big program. We're using little scripts of Python. So that's called interactive Python. And so I forgot to do that. And so all I had to do here is just to say install. So that is just going to open the terminal behind the scenes, and it's going to do a pip install for me. And you can see it's going to run in the right bottom of the screen. I can just let that installation happen. Now that it's done, that cell is actually going to execute. It's going to take a few seconds. In my case, it took 10.8 seconds. I'm really stressing the system because I'm running quite a few things and recording the screen and myself. So that took 10.8 seconds. It's imported all of those. Now you will have to import it every time you create a new notebook. It is installed inside of this folder, inside of that virtual environment. And every time I create a new notebook in that folder, though, you do have to redo these imports. Although, remember, you only have to do that installation inside of the virtual environment once for that folder. So the next section I want to go for is just to import our data. So I'm just going to double click there. Let's say that import data. I'm going to hold down Shift and hit Enter or Return. And you can see I have that second largest font size, and this is where I'm going to import my data. I'm just going to open my Explorer and just remind myself of the CSV file. It was called icu_mortality.csv. That's the file that I want to import. Now for the first time, let's write a prompt. We're going to use a large language model to create all the code for us. And there's different ways we can go about that. The simplest way is to write a prompt right inside of one of these cells. And so what we're going to do is create a new code cell, and I'm going to have a hashtag. Now look at that hashtag. A hashtag inside of a Python cell is very different from a hashtag inside of a Markdown cell. In the Markdown cell, that's going to control the size of the font. But here in a code cell, you can see it says Python in the right bottom there. In this code cell, it's going to tell the large language model that, hey, I am writing a prompt. So I'm going to write the following prompt: import the, and now I'm going to say the name, type the name at least of that file. And what I do like to do is to use little tick marks. Now, so that's not the single quotation mark, it's the little tick marks. Once you type one, the second one's already going to be there for us. And I'm going to write icu_mortality.csv, import the icu_mortality.csv dataset, and I'm just going to say the following: the variable data. And again, I'm going to put that data inside of little tick marks. Now that helps the large language model to discern what the various parts of your prompt would be. And look at that, the code was written for me. Look at that, data equals pd.read_csv, open close parentheses, open close quotation marks, icu_mortality. Now for me to accept that, all I have to do is hit the tab key. You see it went from slightly grayed out to normal color, normal brightness. And that's our code. And again, I maintain this is such a natural way to learn how to code. Let the large language model write the code for you and look at the code that was written. It is unlike, sitting with a textbook and trying to remember where do braces go, where do curly braces, square brackets, all these things go. Just let the large language model write the code for you and inspect that code. You'll learn Python or whatever language you're using in no time. So let's have a look at this. We recognize the PD there. Remember, it comes from that namespace abbreviation. So instead of having to write pandas dot, we just write PD dot, because what we see following the dot, read_csv, that is a function. Now that function does not exist in Python. That function exists inside of this pandas package. So we have extended what Python can do. But I do have to tell, as we've set it up now at least, I do have to tell Python where this function comes from. And it comes from the pandas package, and therefore I have to say pd dot. I recognize this as a function because there's open and close parentheses directly following that. What goes inside of the parentheses, that is called an argument. You give an argument to a function. That function knows what to do. It just has to do whatever it needs to do with something. And that something is instructions or the content. And this first argument, there's only one argument, and we put that inside of quotation marks because it is a string. A string is fancy word for text. And we do want to put those inside of quotation marks, and that's the name of our spreadsheet file. Now, because the spreadsheet file lives inside the same folder as this notebook, I don't have to give instructions as to where this is on my system. For instance, using C:// or /users on a Mac. I don't have to say where this file is. It's in the exact same folder as my notebook. You can see on the top left here, eda.ipymb and icu_mortality.cnv. Because they live together in the same folder, this is the easiest way to go about that. Then we see the equal symbol there, and in most computer languages, the equal symbol is not the equal symbol from mathematics. Instead, it's an assignment operator. Now, what an assignment operator does, it says, I'm going to look towards my right, and I'm going to see what that is. Now, what this function actually does, it's going to take this argument, which references the CSV spreadsheet file, and it's going to create a type of object, and that object is called a data frame. And what it's going to do is it wants to save it to memory in your computer. Now, we have to tell Python where in computer memory this object is going to be stored. And the way we do that is to the left of the assignment operator. And that is this. This is called a computer variable, and that is under your control. You can name your variables whatever you want within reason. You cannot use spaces. You cannot start your variable with a number. You cannot use one of the reserved keywords in the language. Make it something memorable, something like data. Data is not a reserved keyword. It doesn't exist inside as a function or an attribute or anything inside of Python, so I'm free to use that. So that that's a name for the space in memory in which this object is going to be stored, and hence, next time we want to use it, we just have to use that name, data. It'll go to that named part of our memory. It's going to extract this object that we've saved inside of it. So I can hold down Shift and Enter, or Shift and Return, but there's also this little play button on the left-hand side, Execute Cell. I'm just going to do that, and you say there's a little tick mark. It's now in memory, controlled by Python here. Now, when I import a data set, I want to do some sanity checks as a researcher. I want to know that was the correct file that I have. As a researcher, I have a good sense of the data that's inside of that file, so I just want to do some sanity checks. For instance, I want to know how many rows and columns there are. I know when we had our research meeting, how many patients or subjects we already have in our data. And when I check that for this file that I've imported, I know, that we've imported the right file. So there's various sanity checks that I want to do. Now I'm going to remove those sanity checks from my final document because, it's not needed. No one in the research group wants to read that information. But as I'm analyzing this data, I'm going to do those sanity checks. So I'm going to hover in between here. I'm going to hit the code cell again. And I'm going to say, display the shape of the data. And look at that. The code is written for me. I'm just going to hit tab to accept it. And now we see a funny looking code. It's called data.shape. So what's going on here? Data is this object that we created. It lives inside of memory and it has various attributes assigned to it. Metadata. And we get to that by calling the object data. You call it by just typing its name and then dot, and then you use one of the attributes. Now one of the attributes is the shape attribute. And so let's just see what it does by holding down Shift and hitting Enter. And you see it brings back two values inside of parentheses. Now that parentheses is a specific data type, which is called a tuple. A tuple is an immutable list of objects. Immutable meaning it cannot be changed. Now we're not going to use that tuple here, so don't worry about that. What we do see is what's important to us, 311,6. That means there are 311 rows of data, 6 columns of data. Once again, if you're familiar with your data set, you should know whether this was right or wrong. And in my case, this is correct. This is the data set that I'm looking at. I do know that there were 311 subjects in this data set and that there were 6 columns of data. By the way, one thing that is always nice to do is to look at the type of things. Now, I'm going to delete these bits, but we might as well explore a bit. Let's say return the type of data. And there you can see there's a function inside of Python. We know that it's inside of Python because we didn't have to say np dot or pd dot. It's just the function itself, type, so it lives inside of base Python. It is a function because we see the open close parentheses, and the argument is going to be this object, the data object. And if I hit play button now, we see the object type. Now in Python, it's very important for Python to know what kind of object it's dealing with, because as I said, objects have attributes. Later on we'll see they have methods. There are many things you can do specific to a different object type. And this object type has a data frame type. Now you can see the long version of it. It lives inside of the pandas package. Inside of that, there's a core module. Inside of the core module, there's a frame module. And inside of that, there's an object called a data frame object. So we know that data, as it's imported, remember that was caused by this function there, read underscore CSV, that created a data frame object. So it took the spreadsheet, ingested it, and it turned it into a data frame object. Now, as an object, this data frame object, Python knows this thing has various attributes. One of those attributes was the shape attribute. So very important. So I'm just going to delete this because I really don't want that in my report. That's fine. Another sanity check that I like to do is just to print out the first couple of rows of data. Let's do that. I'm going to hit a code cell again. I'm going to write a prompt by saying hashtag space. If it's inside of a Python cell, remember that's an LLM prompt, a large language model prompt. So I'm going to say display and look at that. The large language model already knows what I was going to type. And it says the first 5 rows of data of the data frame. I'm happy with that. I'm going to hit tab just to accept completion of my prompt. That's lovely. And I'm going to hit tab again just to accept that code. And look at that, data.head. So data, again, that's our object. It has various attributes, but not only does it have attributes, it also has certain methods that you can apply to that specific type of object, the data frame object. Now, it's the .head, and you see open and close parentheses, which actually means head is a function. But this is a function that's applied to an object that already exists. And then we're going to call it, just for the sake of simplicity, we call this a method. So in other languages such as R, you would just write head and then you put data inside of the parentheses, because clearly data would then be an argument for the head function. But in Python, things are a little bit different. There are functions that are very specific to a type of object. Now, a data frame object has this function that's very readily applied to that function. That's the head function. And if we use it in this way, we're going to call this head, open close parentheses, we're going to call that a method. So I'm applying the head method to the data object. And if I print that out, hit run, we see a very nice representation of the first 5 rows of data. Now we see all the columns there, and we see the first 5 rows of data. This first column is an index column. You can think of that as that row values that you see in your spreadsheet. The one difference is that Python is 0 indexed, meaning that Python starts counting at 0. So the first object is going to be object number 0. The second object is going to be object number 1. The third one is going to be object number 2. And so it's slightly confusing when you first start using Python that you see things get started at 0. So you can see the first person here died. Their age was 69. Their white cell count was 12. On admission to the critical care or ICU, the HP was 111. And then we see their diabetes status. That was an empty cell in our spreadsheet. That data wasn't collected. So that's a missing value. And then we get, what was the reason for the admission? Was it non-infectious disease or for infectious disease? And that's our data set. So the head function is a very nice sanity check just to have a look at that. By the way, there's also a tail method. So data.tail, and that's going to give you the final 5 values. And inside of these parentheses, you can actually pass an argument and you can say another number like 10, and it'll print out the first 10 rows. If you want to get more advanced, you can also use negative numbers. If you say -5, it's also going to give you back the final 5 values. Now, there's a couple of things that we can do there. But I think for now, for us, this is enough of a sanity check. Perhaps, though, I should show you one more. And so let's create a new code cell. And what I'm going to type in here is a prompt. And I'm going to say display information about the data frame. And there we see another method, data.info. It is a method because the info, open close parentheses, that's a function applied directly to an object. And so that's a method. And if we hit shift return, shift enter, we see something very nice. We can see the type of this object right there. We've seen that before. We can see that there's 311 entries. That's very nice. So it goes from 0 to 310 because remember 0 is the first one. And then we see that there are 6 total columns, and we can see them listed here. The column names, mortality, age, white cell count, hemoglobin, diabetes, and class. And then we see a very important column, not null count. So how many values are not missing? And so we can see in the diabetes column there are 213 values, so there's quite a few missing. And then we see for all the others 311 non-null, 311 non-null, so all the values are there. But for the diabetes, there's quite a few missing. The final column, as far as statistical analysis is concerned, is perhaps the most important because it tells us what Python thinks the level of measurement is for that variable. Now, object, that is, can also be seen as a string, but for us, for data analysis, we can see that as a categorical variable. So in that column, I'm going to get words. And if I look down the mortality column right here, we see died, died, died. So clearly that's a categorical level of measurement for that variable. And that's why it's written as an object. The next one says int64. That's a 64-bit integer. Now the 64-bit just tells us how big these numbers can get. You know, what's the maximum value and the minimum value. So it's going to go from negative, it's 2 to the power 64. And so from the negative side to the positive side can be represented by a 64-bit integer. Now integer means a whole number. And if I look down this column, indeed we see a whole number, 69, 73, 53. The next one that we see is float 64. That's the 64-bit floating numbers. And if we look down there, we see that floating point numbers is just fancy speak for values with a decimal place. And indeed we see that. We also see that for the HP column. Now, one good part about this is that sanity check. If you see white cell count and hemoglobin and age, you really think that those should be numbers. If you suddenly see object there, then you know something went wrong. You know, someone might have missed, put a letter in there somewhere. They wanted to type 64, but maybe they hit the 6, the 4, and the E key, or they typed in 60 SIXTY. Something went wrong. So this is another nice way to do a quick sanity check. It also reminds you of the columns that you have. Now, if you have a very big data set and there's a lot of superfluous columns, what we would do at this step is just to select only the columns that we want to work in, and we get rid of all the others. Now we don't have to do that. We've only got the 6 columns here, so we're happy to go ahead. So that's enough of a sanity check, and what I usually do is I will delete all of these. I've done my sanity check now, and I really don't want these to appear in my final report. So if I come here right to the cell here, click inside of the cell, right at the top you'll see there's a little trash can icon. I'm going to hit that. For the next one, hit that. For this one, I'm going to hit that as well, because I really don't want for this to be in my final report. By the way, I will open the markdown cell here and write something about this data set. Remember, this is going to be a research document, a computational essay as we refer to it. And so we might as well, add some extra text for those that we are going to share this document with. Maybe others in our research group that don't know how to code and don't know how to do data analysis. So I'm going to hit that markdown right there. As you can see, it's going to give us a new cell, and I'm going to say something like that. In this section, we import the data from the ICU project. Now you can go ahead and type normal English there, giving us a data dictionary, telling us a little bit more about these variables. You should really be very verbose in these sections. Just write there, as much information as a potential reader might want to see. I'm not going to do that. I'll just accept this bit, and you can see it's normal English text. Now the next thing that you're always going to do when you do a research project, you are going to do summary statistics and data visualization, so exploratory data analysis. No matter how tedious it is, that data wants to tell you a story, and it's your job to extract the meaningful information, the story that this data is trying to tell you. And the first way to go about that is just do the very basic summary statistics. So we're going to do summary statistics data visualization that combined is exploratory data analysis. It'll tell you what's going on inside of your data. It might also highlight problems with the data collection. If you suddenly find an age, minimum age of -16, something went wrong. If you suddenly find an age of 184, something went wrong. And so you learn about your data. It starts to tell you, what your statistical tests are going to look like. It really gives you very good insight into your data and should never ever be skipped. So the next section I'm going to do is Markdown again, and 2 hashtag symbols. I'm keeping that constant as far as my sections and subsections, etc. is concerned. And so I'm going to say EDA for exploratory data analysis. Let's put another Markdown cell there. I'm going to start with the very first column, and that was going to be my age column. Now I want to put 3 hashtags there, so that's going to be a subsection. And we're going to start with the age column. Now, once again, I'm going to put a Markdown cell there and say something about, the age, if there is something to say. If not, let's just go ahead and do some data analysis. Now, what you can always do, remember, we can create a cell and we can just remove that cell. So I'm going to do that same thing again. I'm going to say data.info, open close parentheses. There we go. And I'll just keep it here at the bottom just to remind myself of what was going on. I'm going to start with the age column. That was one of our explanatory variables. The mortality is going to be our response variable, so I'll leave that one till the end. So for age, we know it's int 64, so I know it's a numerical variable, and we can just do all the things that we would do with numerical variables. So the way we're going to do about that, now I'm going to leave this one at the bottom because I'm just going to delete it in the end. I'll go one cell up, put in code. Now let's write a prompt again, and I'm going to say calculate summary statistics for the, and I'm going to say again inside of little tick marks, age column, I'm going to put A as an uppercase A because that is what was done there. Calculate summary statistics for the age column using the, let's do that, using the describe method. Yes, that's exactly what I wanted. Now look at that. The LLM made a mistake and then recognized that it made a mistake and immediately corrected it by putting this little green area there. I can click on that green area or on this little tick mark. I'm going to accept that change that it made. So it got it wrong the first time and then realized its mistake and then wrote the correct code. That's absolutely lovely. So let's just analyze this code. So it says data, that's our data frame, and then square brackets, that is called indexing. And what do I want to index? Well, I want the age column. And I'm going to put that in single quotation marks. You can also use double quotation marks. So those are not tick symbols, they're quotation marks. And this little bit here just gives me back the age column. Instead of the whole data frame, I now get the age column. And that's actually called a series object, but don't worry about that. Then we see there's a very nice method, which is a function applied to an object. There's our object, dot describe. Open close parentheses. If I hit enter return, look at this. Summary statistics. Lovely. I see the count is 311. The mean was 56.457, thereabouts. The standard deviation, 10.97. The minimum was 23 years old. We see the first quartile, the median, or 50th percentile, which was 56. We see the third quartile, and we see the maximum. That's absolutely fantastic. All your summary statistics done for you in one go. Now let's do some plotting. Now I'm going to go straight up to the top because there's something I want to change in my import section. I'm going to create a new code cell there. Now if you're working with a high dots per inch, a high resolution display, you can get high resolution graphics. By default, Matplotlib is going to create low quality graphics, or low resolution graphics, I should say. Now the way to do that is to use a magic command. Now a magic command is these few special things that you can type that instruct the notebook how to do certain things. And the one that we want is the following. Now you can just memorize this because if you have a nice high resolution monitor, you want to do that all the time. We also want to copy and paste maybe these plots into a Word document that might serve as a manuscript that we want to submit to a journal. So it's always nice to have high resolution plots. So it's going to be %config. And look at that. I see the autocomplete. I'm just going to hit the tab key to accept that. It says inline backend.fig_format equals retina. So for retina displays, that's just the default word that is being used for these high DPI monitors. So I'm just going to hit Shift and Enter to accept that. Now I'm going to get back high resolution plots. So let's go back down. I'm still busy with the H column. So I'm going to hit the code cell. And what I want to do now is to say create a histogram would be a nice way of the H column. Now, by default, it's set there with 20 bins. Now, we're probably going to change that, but let's accept that for now. You can see it's already written some code for me, but I'm not done writing my prompt. So I'm just going to hit enter and see it's still slightly grayed out. So I can just keep on typing. I'm going to put another hashtag because I just want my prompt to continue on the next line. I'm going to say add a title named. Now I'm going to put it inside of quotation marks because this is what I want the title to look like. It's going to be a string. So in other words, characters and words. So I'm going to say distribution of age. That looks nice to me. And if there was any kind of spelling mistake or anything, it's going to highlight that for you. You can just click on the green and accept that. That's great. I'm not done yet. I don't want to go straight to that. I'm going to hit enter again, another hashtag symbol. I'm going to say label the x-axis age. That's fine. But I also want the units. Oh, look at that. It's done that for me. Years. Next one. Again, I'm going to say add the y-axis number of patients. That's great. I'm not done yet. I'm going to say add a grid. Add a grid to the plot. That looks good. Now I'm happy. Now I'm just going to keep on hitting tab and let the large language model write all the code for me. That's fine. That's fine. Everything looks great. Now, how do you know if it's done or not? Well, you don't really know. So I'm just going to hit enter again. And there we see plt.show. Now, plt.show means, actually show the plot. So that's the one that I want. A nice little trick, though, is once you see plt.show, just put a little semicolon right at the end. Because when these plots are created inside of the Jupyter Notebook environment, you are going to see that it puts this ugly line of insider text, text that it requires that has information about the plot. We don't want to see that. We just want to see the plot. And the way that we suppress that output is just by this tiny little semicolon right at the end. So you can inspect this code. You see it's PLT. Remember, that was matplotlib.pyplot. Inside of there, there's a hist function. So plt.hist, that gives us a histogram. What do we want to plot? Well, we want that age column. Now, it said bins equals 20. I'm not really going to accept that. I don't really like that. But let's go with it for now. You'll see the problems later. plt.title, plt.xlabel, plt.ylabel, plt.grid, plt.show eventually. So let's run that. And there we see a nice enough looking histogram. Not ready to submit to a journal as part of your manuscript, but it's certainly getting there. Now, one of the problems that we can see is it created 20 bins, but the bounds for these bins are just wild. I would certainly like them to either be per decade or at least every 5 years, but I want to start it at, values that are divisible by 5. Now, the way that we're going to do that is we've got to look up here. We see the minimum age was 23, so a nice place to start would be at 20. The maximum was 85, so a nice place to end might be 90. And so let's start at 20, go up to 90, but let's do that in steps of 5. That would be very nice natural breaks for these bins, for the intervals of my bins. So how are we going to do that? Well, we can just tell the large language model to do better. So let's create another code cell. I'm going to say recreate the histogram, and I'm going to say age column. That's fine. Let's add. Start the bins at 20 and end at 90 in steps of 5. Okay, that looks nice. Everything else is still going to be the same. And look at that. Now we have bins equals range 20 to 95 in steps of 5 instead of just saying 20 bins. Let's execute this and see what it looks like. That looks a lot better. Now we can see that these bins are lined up, by half a decade. So 20 to 25. So there were a couple of people in that. Between 25 and 30, there were no people. Between 30 and 35. So just, make it, a sensible decision for you. And you can certainly just go with that. Now, there's lots that I would still change with this. I want to see some outlines to these rectangles. I certainly want to get rid of these black lines, that's called the spines around that, but I leave that to explore. Can you express yourself in a prompt to try and get rid of these? Now, one thing that we haven't looked at is look at these 3 buttons there. Copy to clipboard, expand image, and save as. So you can just save these images to your internal drive, and later on you can just copy and paste them, say, into a Word document. Now I've got 2 versions of this plot. I don't really want that. So what I would like to do is just to delete this one. But if I delete this top one, look at this. All it says is recreate the histogram. That doesn't make sense to anyone who's going to read this after the fact. So what I tend to do is take this prompt right up there. Now, again, this is just, for neatness sake. I'm going to copy that and I'm going to replace this recreate and paste it right there. Now that whole prompt looks good. And again, it might be a prompt now, but when someone reads this document, maybe they don't understand code, they can just still read all these instructions and it'll tell them what the code's going to do. So it serves 2 purposes. Instructs people who don't know how to code what you're trying to do, and it is a prompt to the large language model. So I can go up to this one and I'm just going to delete it. So that looks great. I've got age and I've got summary statistics and did a visualization of that. Now do remember, say something about it. So I'm going to put in a markdown cell and I'm going to say, type as much as you can here. I'm just going to keep it brief now. I'm just going to say the age was near normally distributed with a sample mean. Now let me show you a little bit of magic. One thing that you can do in these notebooks is use LaTeX. LaTeX is a mathematical typesetting language that you can use right inside of your markdown cells. Now there are 2 types of mathematical typesetting that you can do, inline and display. Inline meaning your mathematical notation is going to go inline, right in the sentence. Display is when it's going to do an extra bit like a mathematical textbook, printed right in the middle of the page. Now I'm going to do inline, and inline is just a dollar symbol and another dollar symbol, and I'm going to put something inside of those 2 single dollar symbols. And I'm going to say the following: \bar, curly braces, x, close curly braces, equals, and what was the mean? It was about, let's say, 56.5. 56.5, and then years. So that's inline LaTeX. The markdown will know that it's LaTeX because we have open and closed dollar symbols with no spaces between that dollar symbol and the backslash, and between that 5 and the dollar symbol. The \bar is specific LaTeX code. It's going to put a bar over any letter that we type there. This is a random variable age, so we're going to use x, and then we're going to say equals 56.5. Let's execute this and I'll show you what it looks like. Look how beautiful that is. There's my x bar equals 56.5 years. So it's well worth the effort to look into LaTeX just a little bit. Allows for beautiful mathematical typesetting right inside of your Jupyter notebooks. Now what I want to do now is just to remind myself of one of the categorical variables. We might go for this mortality that was our response variable of interest. But what I want you to do is, for your data set, again, delete all the columns that you're never going to work with so that you don't have too many. You're going to go through each and every one of your columns. That is part of being a proper researcher, data analyst, statistician. You want to look at each and every one of these columns. Don't skip that. And do remember to add much more information in this normal English section than what I've just written here. I want to see a lot of information there because, not everyone understands this code. Not everyone understands what's going on here. This is a living document. Years down the line, when someone wants to look at this again, there is living proof of all the analysis that you did. It's a very nice research document called a computational essay. Now, the next one that I'm going to go for, as I said, is just mortality. So let's do markdown again. Remember, we're at 3 hashtags. I'm going to say mortality. And again, I'm going to put markdown there and say something about the mortality of this research project. So that's very important. But for now, all we want to do is some summary statistics. Now, this is a categorical variable. In other words, only thing we can do really is to count the categories inside of this categorical variable. So the unique elements or the sample space elements. So let's hit code, and I'm going to write an LLM prompt, and I'm going to say, calculate the frequency of each unique value in the mortality column. And look at that, it's done written the rest of the prompt for me. I'm happy to accept that. I'm happy to accept that code as well. It's seen that I've made a typo, so I'm going to just click on that green. So it's corrected that for me. Now look at that, data, open close parentheses, mortality as a string, then dot, and then value counts. That's the method that's going to count the frequency of each of the categories or unique values in that column. So if we run that, we see 207 survived and 104 died. So it found those 2 unique categories in that column, survived and died, and is going to give us back the count. Now, maybe you want that as a proportion, so let's just do that as well. So let me create a new code cell, and I'm going to say calculate the relative frequency of each unique value in the mortality column. And I'm going to accept all of that. And you can see the only difference now was there is what is called a keyword argument. A keyword argument is an argument that has a name and a value assigned to it. Remember, the equals is an assignment operator. So normalize equals true. If I add that little bit, I'm now going to see the proportions. So 66.559% and 33.441%. Now, if we want to see that as percentage, I'll leave that to you. All you have to do is multiply by 100. But write that little prompt and see what that's going to do for you. So now we need some data visualization. So let's create a code cell. Now, good data visualization for categorical variable would be a bar chart, not a pie chart. Never, ever, ever a pie chart. So I'm going to write hashtag, and I'm going to say create a bar plot of the mortality column. Now, look at this language model. It's learned that I don't want just to see the plot, that I want some extra information in my plot. And look at what it's done. It's written some more prompts for me, part of the prompt at least. So add a title, mortality distribution. I'm just going to accept that, although I might say I want something on the horizontal and vertical axis. But let's just go there. And look at that. We have data.mortality.valueCounts.plot. So it's getting kind of complicated, but I think by now you can sort of see what the structure is going to be. Title, oh look, it's put an X label and a Y label, even though that wasn't part of the prompt. So that's fantastic. Let's run this. And there we go. We see a nice enough bar chart. We see survived, and how many did we have? 207, and died we had 104. Now, once again, put a markdown cell here and add as much information, in normal English as you have seen with your summary statistics and your data visualization. So that's where I want to leave it for now. I'm doing the univariate summary statistics and data visualization. Next, I'll go on to comparative summary statistics and data visualization. We'll do that in another video. Now, what I'm going to do there is take my response variable. There were clearly people who died and survived. And this time I want summary statistics and data visualization of all my explanatory variables per category in that response variable. So I want to know the mean age of those who died and survived separately. I want to do that summary statistics and then the histogram or a box and whisker plot separately for those who died and survived. I want to see a separate bar chart here for survived and died as far perhaps as the diabetes column is concerned. How many who survived had diabetes and didn't have diabetes? How many who died had diabetes and didn't have diabetes? So comparative summary statistics would be my next step. And it's only when you've done this univariate and then the multivariate summary statistics and data visualization that you can start thinking about your research questions. So that's how you do this. Please do remember to be much more verbose in your markdown cells here. Every time you've done some analysis or created a plot, write some English text about that. That is very, very important when it comes to these. Don't just have a document full of analysis. So what we've really seen there, we haven't touched this right-hand side. Look at this big area on the right-hand side. You can see I have an agent. I can just ask, I can edit, and I have this list of the list of large language models I can choose from. We haven't touched any of that. We will certainly do that in a next video. By the way, though, you can experiment with it for now. Please just put it in the ask mode, and then do remember to choose a model that's of your liking. I specifically like Claude Sonnet 4. It does very well. I'm still experimenting with the 4.5. It's still creating a bit of some errors for me. So Claude Sonnet 4 is actually quite good. And if there was an error, if your code produced an error, you can just highlight that part that had an error, and you can come down right here in the bottom right hand side and say, this code that I've highlighted created an error. Can you fix it for me? Just write your prompt down here and then hit this little play button there, and it'll go ahead and make suggestions and try and correct that error for you. So you don't always just have to write prompts here. Now, fortunately for us, all the prompts work fine, but if there were some errors, I would just highlight that and then come down here. I would, as I say, put it here in the ask mode, and then choose your model and just write your prompt right there. You can see there it says EDA.IPYNB, so the model down here will know this is the notebook that we're working on, and say I've highlighted some code that produced an error, can you fix it for me? Something like that. But we will certainly explore that in a future video.